in this system. So either you can make a similar range of ambient condition, or you can increase the range to check the how much saturation point of the plant. Okay, so there is a one more fluorometer separately if you get, so they can give you photosystem 2 parameters also, like ATR, quantum efficiency, quantum yield, whatever parameters, zero fluorescence, maximum fluorescence, non-photochemical quenching. That instrument is also given by this PSI also. But that range in this instrument should be more higher than that. So whatever the parameters are responsible for the photosynthetic gas exchange, that is airflow, humidity, CO2, light, temperature. These are the 5 parameters that is important for the photosynthetic parameter. So you can control these all 5 parameters, and these all 5 measurements are directly measured by this equipment. And there is a further another more parameters like photosynthetic rate, estimated conductor, that are responsible for these 5 parameters. Okay. So now I can, whatever the gas exchange parameters required in the plant, you can get by using this equipment. Okay. So here there's a many functions are there in this instrument. So first we go with the chamber setup. So there are 3 different apertures we have provided: 1 into 3, 2 into 3, 3 into 3. So if you have a leaf less than 1 centimeter of width, then you can use 1 into 3. Then it is broader than 2 into 3, and if it is more than 3 into 3, it is better to use the broader leaf than that aperture. Means your leaf size should be more than that aperture size. Okay. So you cannot do anything in peripheral step. You go into the configuration. So we already added one configuration to add all these parameters. You already like here we selected all these parameters, and then load configuration, and this configuration comes, and whatever measurements you have did, you will get all these parameters. Okay. Yeah. So there's another step, that is warm test. This is a very useful step when you are feeling that your instrument is not working properly. So it can check all the parameters. It can give you the whatever that happens in the instrument. If it's something wrong, that is warned, and if it is not working, then it is failed. And it also gives suggestions also. Maybe that suggestion 90% accurately you will follow that steps, and you can rectify your instrument. Then there's a data dictionary. In this, whatever the measurements inside this instrument, you can get the details of this, like what is CA, what is PCA, what is A estimation. These details are here. This is also available on manual and online manual also. But at the time of measurement, you will also get from the data dictionary which measurements means what. Then we go into the system settings. These are the basic things: date time, brightness, time zone. These are the basic things which you control by system settings. Okay. Then there's a standby and power off. When you are not doing anything, you want to switch off this instrument, then you can all control off. When you want to, in between measurement, you want to relax and come back and again without doing again all the settings, then use sleep method. Again uncheck the sleep method and you start from the measurement. Okay. Then there is a constant option. In this constant option, you cannot do in system anything, nothing you can do. Go into gas exchange. When your leaf width is less than 1 centimeter, then you can check by any scale, or that it is 0.5 or 0.75. Then you can put this leaf width here, 0.75. Then automatically the area should be changed, and whatever the measurements you will get according to that area. So here there's a leaf temperature option. There's a 2 type of temperature sensor are here. One is a thermocouple and one is thermistor. So when it is measured in with the help of a thermocouple, E-fine thermocouple, then it used this measured option. When this maybe some chance that it can be damaged, then it go into energy balance, thermistor balance. These are the things we cannot change. There's a range match, just need to check, verify. Nothing you can do in user. Then the main step is your environment. So in this environment, you can switch on all the parameters. Flow should be 400 to 500. Normally in the area of the agricultural field or plain lands, use airflow around 500 micromole. And you can also check if there is a leakage in between the leaf. So there's a 9% leak, so you need to check that where it is. It may be a some gaps in between or maybe some dust also. So you need to clean and then you can use. Then H2O. So in H2O you can check the relative humidity range. Relative humidity for the plants fix at least from 50% to 75% or 70% of humidity. In that range, the plants can do photosynthetic activity. If it is less than that, there is chances of stomata closing. So you can fix this humidity 50%, or you can also check as per the environment condition. If it is goes up to 60, 65, then you can fix 60 to 65 also. So that will help to the plant that it will at the same environment condition and it can do measurements as early as possible. Then we have already punctured the CO2 injector. If you don't want to use CO2 cartridges, you can also do the measurement by controlling. There is one a long pipe you can put into any small box that is closed, so that environment inside the CO2 is should be fixed. So if you don't want to use CO2 cartridge, then you can also use this equipment. Okay, now you can switch on the CO2. Normally in the environment it is around 400, so you can fix this CO2 400. Then you can switch on the fan. Fan should be 10,000 RPM. Temperature, it should be similar to ambient, so it is 25 around. So I just switch on and change this around 25. So it is also dependent upon your experiment. If you want to check any temperature variation in your plant, how it affects in the plant also. So you can change plus minus 10 degrees Celsius above or below the environment temperature. And in CO2 you can make a CO2 response curve up to 2000 micromole, from 0 to 2000 micromole. Okay, and there's a light also, you can control up to 0 to 3000 micromole. Right now in ambient there is a just 100. Right now there is just 100 ambient light, but it cannot do any measurement in 100. So we can
1000.
increase the around 1000. We can fix this around 1000. Okay, and there is an option that you can also make an blue and red combination. Some plants can do photosynthetic activity in red also, so you can make some changes. Red and blue combination, 90% blue or 90% red, like this.
The light is off.
Okay, and there are some auto control methods. So now we go into first. There's a, I just tell you the programs. There's a multiple programs are there. You need to select before starting the measurement. So there is a none method. This none method you can do manual logging only. When you use this CO2 response curve, in this you can put some range and you will get in that particular range, it can stabilize the equipment and you will get the photosensitivity and other parameters in that particular range. There is a similar light response curve also. You can give some light intensity. Yesterday we checked this in this light ranges, and we found that in that particular plant the maximum efficiency at twin light is 1200 only. So you can make a response curve and found the saturation point of that particular plant. Okay, so there is other programs are also there. So there is a dynamic method is also there. So you can make a CO2 continuous method that at particular interval maybe photosensitivity should be higher, maybe 642, 650, whatever. So how to find you? By using this method, you will get at a particular range of saturation point of CO2 concentration, that after that the plant cannot take more CO2. So that is another method. And there is a generic response method also there. So in this you can make an program according to your requirement also, but you need to know that what this program helps you in your plant and whatever you want to find. थोड़ा सा एक दो बूंद चलेगा, कोई नहीं. Okay, then we go into the, I think the polyhouse में ही चले जाते हैं. Stability option, you need to find that your instrument is stable or not stable, and then you go into this open a log file.
क्या करना है?
Create a new file.
First polyhouse. You have to shift this along.